In this question, we're given the energy level diagram of an atom, and we're asked some questions about some different things. So it says, which is the ground state? Well, the ground state is the lowest energy. So in this case, E is the ground state because it's the lowest energy. How many excited states are there? Well, other than E, there's 1, 2, 3, 4 states. So those 4 states are all excited states. So this is the ground state. These are the excited states. So there are 4 excited states. This is a tough question. It says, how many lines are there in the absorption spectrum? We need to consider all possible absorptions. Remember that an absorption is a photon going, or excuse me, an electron going from a lower energy level to a higher energy level by absorbing a photon. So there's 1 from E to D, 2 from E to C, 3 from E to B, and 4 from E to A. But those are not the only 4, because you could also have an electron already in an excited state like D go to C. So there's a 5th from D to C, a 6th from D to B, and a 7th from D to A. Also, you could have an electron in C absorb a photon and go to B. So far we have 7. There's 8 from C to B, 9 from C to A, and finally 10 from B to A. So there are 10 different absorptions that can occur in this molecule. So there should be 10 absorption bands in a line spectrum. Which transition causes the emission line at the shortest wavelength? Well, the key here to look at is short wavelength. Short wavelength means high energy. So what's going to be the highest energy emission? Well, an emission is going from a higher energy level to a lower energy level. These are all absorptions going from a lower energy level to a higher energy level. But here, the highest possible emission that we can get is from A to E. That'll be the highest energy and the shortest wavelength. So short wavelength means high energy. So A to E is our answer. Next, it says which transition causes the emission of the longest wavelength. Well, long wavelength means low energy, so we want a small energy gap. And here, the smallest energy gap is going to be between A and B. So A to B will give us a long wavelength or low energy photon. It is also important to note that in the energy levels, they get progressively closer together as you move farther away from the nucleus. So I'm not sure what's going on here with C to B. They should get progressively closer together.